You're welcome to Exam Scholar channel. This is your first time of coming across this channel. Kindly subscribe to this channel.
So in this video, we are going to learn about wave.
Now, just make sure you watch this video to the very end. And you'd like this video? Alright, let's start.
Now, that is what? That is a disturbance. Wave. Now, we are going to learn everything about wave. Have you ever remembered that when you get to an empty room, there's nothing inside the room, you just walk into the room and you started shouting, do, do. Now, you are actually disturbing the peace of that room, isn't it? You are making noise, isn't it? All what you are doing is you are making wave disturbance. Just imagine as you are watching this video, you see that I disturbed your eyes. I'm creating wave. Now that type of wave is what? Electromagnetic wave, light wave. Now the following room in which you are in the empty room and you are just disturbing the peace of the room by shouting, you are making sound, isn't it? And because you are using the sound to disturb the room, you are creating wave. Now, have you ever wondered how light travel from a source to another place? Or have you ever wondered how we speak and people can hear us? All these things are possible because of an energy carrier which we know as wave. Oh yeah, come here. Let's define wave. Come here. I know you are going to tell me that is a disturbance. Abi is a disturbance. Okay. All right. Let's explain disturbance. When we talk about disturbance, disturbance means imbalance. You are creating something that is at peace. You just come about and then you started creating a lot of things. Okay. All right. Now, when a room is at peace, you are making sound as I'm making sound. That's a disturbance. All right. Let me disturb your ear. You can see that is a wave, sound wave. Now, wave is now a disturbance that travels in time through space. It's not just traveling in time, it is traveling through space and is carrying energy from one point to the other. Recall that when we are making sound, we are creating sound energy, isn't it? Okay. When you hold your torchlight, that is what? Light energy, isn't it? Okay, you are clapping your hands. You are making sound, isn't it? Alright, sound energy. Okay, now when there is earthquake, okay, the ground will shake. Okay, seismic wave. That is what? That is wave. Alright, and all these things are energy, isn't it? Now, wave is now the one that is carrying this energy carrier from one point to the other, and there is one particular thing that you must see when you are divining wave. All these things are happening without transferring of matters, without movement of matters. So, which means that there will not be permanent displacement of the medium. So yeah, let's combine everything. Wave is a disturbance that travels through time and space, transferring energy from one point to the other without permanent displacement of the medium, without transferring matters. Let's see how to classify wave. Like if you want to classify human being now, you are going to say we have a male, we have a female, we have short, we have tall, we have short, we have fat, we have thin, we have black, we have white, we have Oyibo, we have Africans. Now the same thing applicable to wave. We can classify wave using different method, using different approach. All right. Now if you want to use color to classify man, you say we have black man, yellow man, white man. You want to use height, tall, short. You want to use size. Robust, fat, thin, slender. Okay, now let's apply it to wave. Now you can classify wave according to the medium of propagation. Since wave is carrying energy in time and space, there should be a medium in which wave is using to carry that energy. There should be a medium, isn't it? Now, medium of propagation, when you now use it to classify wave, we now have the first type of wave that requires a material medium. It always requires something for it to move from one point to the other, from one source to another place. Is going to need material medium. Material can be what? Liquid, solid, and gas. So it means that it will require either solid medium, liquid medium, or gaseous medium. Now, this type of wave are known as mechanical wave. So mechanical wave, there are types of wave that is formed by vibration, and the wave that is generated will require material medium for its movement, for its propagation. Now, let's do a practical. Okay, let's do a practical. And when you get inside the car and you wind up, what will happen? Shout till tomorrow. Nobody will hear you. Because sound energy, sound wave will require air, isn't it? Okay, now let me say this again. It is not only air that is serving as a medium of propagation for sound wave. Sound can travel in solid, it can travel in liquid, and it can also travel in gaseous medium. All right, now let's break it down. Come here. Calm down.
You see this sound that we are talking about, okay? It has different speed in different medium. Speed. Okay.
Now, sound wave, we have speed, different speed in different medium. One of the defining thing about the speed of sound wave is the medium of propagation, isn't it? Calm down. Sound wave will travel faster in solid medium compared to liquid medium, then compared to what? Gaseous medium. Let's draw it from solid to liquid to gas. Now, the speed of sound will be greatest in solid medium, e.g. melter. Now, we have talked about mechanical wave. It is caused by what? Vibration. Example of mechanical wave, we have fan wave, we have water ripples or water wave, we have seismic or shock wave.
Those are examples of mechanical wave.
You can now classify wave that is not requiring material medium. This type of wave, they move in free space. Free space means vacuum. They don't require material medium. They just move on their own. Either there is air, they will shall travel. There is no air, they will shall travel. Either there is solid, they will travel. There is no solid, they will travel. Hello, you are disturbing me now. You are just calling me. Why are you calling me? I beg. And you see the call that I just made. That is actually the type of wave that we are talking about here. Why is it possible that I can hear what that person is saying? That person is calling me from a far distance. It is not the ear that blows the sound into my phone. There is something that carries the sound from where he's speaking, and that's inside my phone. And I can hear that person simultaneously as he's speaking. I'm hearing him. It means that there is a wave that is carrying it. That type of wave, either that person is in the ground, in the water, so far that person is calling me and is using that wave, I'm going to hear that person. So which means that wave doesn't require material medium, unlike sound. Now, this type of wave, they are known as electromagnetic waves. Now, electromagnetic wave, they don't require material medium for their propagation. They travel through free space. Let me give you an instance. The pregnant woman, they used to go to hospital. Okay, they are going to take scan. Now look at it. The wave that they are generating, X-ray, is going to penetrate. It's going to see the inner structure of the pregnant. It's going to see that baby. That is electromagnetic wave in action. When you want to touch light, visible light, electromagnetic wave. It doesn't require material medium. Now, this wave is coming from the interaction between electric field and magnetic field. That is why we have electromagnetic wave.
So examples of electromagnetic waves is we have radio waves, microwaves, infrared, visible light, ultraviolet rays, we have X-ray, and we have gamma rays.
Let's look at another classification. We can classify wave according to the flow of energy from the source. How is energy flowing from the source? Let's go. We have standing or stationary wave. Now, you see this standing or stationary wave. Now, you see this one. Energy is not flowing. Let me come again. You see this standing wave? Energy is not flowing from one end to the other. Unlike another type of wave that we are going to talk about. You see, this standing wave is formed as a result of interference of two waves. The one from the source and the one that is reflecting on the surface. So we are still going to talk about this. Now let's understand the other type of wave. So we now use it to understand standing wave. We have another type of wave that is known as traveling or progressive wave. Traveling, on travel is traveling, on travel is traveling. Now we have progressive wave. Progressive, something is in progression, moving. Now for traveling wave or progressive wave, now this is a type of wave that is carrying energy. Is carrying energy. The energy is actually moving from one point to the other. There is no stoppage of movement of energy. Now let's now go back to standing or stationary wave. For standing or stationary wave,
instead of transferring of energy, the energy will now be in the vibration of the wave. So the energy will be in between the wave. The energy will not flow out for stationary or standing wave.
Example of standing or stationary wave, they are what I just shown you now. Flute, guitar, bang. Now all those waves that is generated from them, they are known as what? Standing or stationary wave. Now what about traveling or progressive wave? We have many of them. When you want to touch light, that light will be traveling wave. When I clap my hands, the sound that is generating is going to traveling wave. Now, we now have classification of wave according to the direction of flow of movement of wave. Now, let's now look at it. We have what is known as transverse wave. Transverse wave. Now, transverse wave are a type of wave that is traveling perpendicularly to the vibration of the source. This one is traveling what? Perpendicularly to the vibration of the source. Now we have longitudinal. This one is traveling parallel to the vibration of the source. Let me give you an instance. For transverse wave, all electromagnetic waves, they are transverse wave. I repeat, all electromagnetic waves are transverse wave. Now, what about longitudinal wave? Example of longitudinal wave is sound wave. Sound wave is longitudinal wave. Don't forget that sound wave is also what? Mechanical waves. Sound wave, they are mechanical waves and they are longitudinal wave. Okay? Electromagnetic waves, X-ray, visible light, gamma ray, ultraviolet ray, radio waves, infrared, and the light. We have 7 of them. Those ones, they are electromagnetic wave and they are also transverse wave. Okay? Now, another type of transverse wave is, we have one example of mechanical wave that is transverse in nature. That is water ripple. Water waves, they are transverse wave. Let me show you. What you just saw now is water ripple, water wave. What are the properties of wave? The features of wave. The first one that we are going to talk about here is called reflection. Wave can be what? Reflected. Now, what is reflection? Reflection simply means the change in the direction of wave. Let me show you. Change in the direction of wave when wave encounter an obstacles. That is called reflection. So wave have these properties. Change in the direction of wave when it hits an obstacle. It's going like this before. After encountering obstacles, it changes direction. Just like when you use your mirror to change the direction of light. That is known as reflection. Reflection of wave. We have refraction, reflection, refraction, reflection, refraction. Okay. Now, reflection of wave is the change in direction when we are talking about just a single medium. Now, change in the direction when you have multiple mediums. When wave is traveling from one medium into the other, the bending or change of the direction of wave is called refraction. Refraction. So, refraction simply means what? Reflection or change of direction of wave when the wave is coming from one medium into the other at the interface of two media. All right, let me show you. Now let's have this diagram. The wave is coming from the ear, it enters into this medium and it leaves this medium. Now let's look at it. It's traveling like this. Let's say this is ear and let's say this is glass. When it enters the glass, it bends. Can you see the bending? This is known as refraction. Now, when it moves out of the glass of this medium, it also bends. This is called refraction. Now, refraction is taking place in two places. Now, we have the between these two media. Let's say this is ear and this is glass. Between ear and glass, refraction is taking place at the interface, the boundary of the two media. Now we also have refraction here, which is taking place between the glass and the ear back. So this is refraction. Now, refraction can also take place at the interface of multiple media. So let's look at three media here. Now we have here, let's say wave is traveling and it enters here, so we are going to have this. So we have this is called refraction. Now we have diffraction. Come again, diffraction. Come again, diffraction. For diffraction, when wave moves through a small opening, that wave will now bend or the wave will spread out. Let me give you a practical example of diffraction. And just imagine you are in your room and you close all the door. You don't want to hear any sound coming from outside. Now let's say now there is now a small hole inside your room, or you open the door a little bit and people are talking outside. What do you think will happen? The sound that is coming from outside will bend and it will enter through the small opening. You are going to be hearing the sound. So which means that the sound wave will diffract, coming in through the small hole, through the small opening that you have created in your room, and you will still be hearing the sound coming faintly inside the room. That is known as diffraction of wave. The same thing applicable to when you open your door a bit and sun is shining, you are going to see the ray of sun coming through the small opening. That is known as diffraction. Okay, now this is the meaning of diffraction. As the wave is coming in, entering through small opening, then it spread out. This is diffraction. This is diffraction, spreading of wave or bending of wave around a small opening, aperture, or obstacles. That is what we call diffraction. Now to the next attributes of wave, that is called interference. Now, to learn interference, we need to understand how waves behave when we have multiple waves. So let's understand something about them. That is what we call superpositioning. Superpositioning of wave. When we talk about superpositioning of wave, we are saying that when we have multiple waves that they are interacting, and they are going to have a resulting effect. So when you have two waves that is interacting with each other, we are going to have a resultant wave that is having its own amplitude. That is what is known as superpositioning. So when waves interact, when they combine together, when they move through each other, we are going to have superpositioning of wave. Now, when we are not talking about superpositioning, that interaction, and when waves move, combine together, move in one another, that is what we call interference. So which means that wave can can interfere. Let me give you a practical example of interference. I used to explain something. Let me tell you what I used to experience. I'm going to demonstrate it for you now. We used to start our own program early. We used to start our own program early. Now, during the time that we are having our preaching, that the pastor is preaching, the pastor will just be preaching with the mic. Come on, give your life to Jesus Christ. Everybody, raise up your hand and glorify God. Today's service, we are going to look at the topic that says, come on to Jesus. Now, immediately we are hearing that, then we now be hearing, Oluwa, Eshe, Oluwa, Eshe, Oluwa. Everybody will now be like, what happened? Where is this sound coming from? We are preaching, we are not singing praise and worship. What happened? This is called interference. This usually happen in church, in mosques, when the microphone is picking signal from outside. The signal is not interfering with the signal of the microphone. So that is what is known as interference. Now, interference, let's have a diagram. You see this wave, yellow wave, white wave, they are interacting, moving. Look at them. Let's observe something. This white wave and this yellow wave, they have the same frequency. They have the same amplitude. The maximum displacement is the same frequency. Now look at what happened. This one is starting from this point, moving like this. This one is starting like this, moving like this, and they are interfering. We have types of interference. We can have constructive, we can have destructive. That destructive is of two types. We have total destructive and partial destructive. So let's start by learning total destructive. Now, for total destructive interference, the two waves must be identical. They must have the same frequency and they must have the same amplitude. And the two waves should be completely out of phase. The phase angle between them should be 180 degrees. So if one is at the top, the other one will be at the below. But let's see. Now we have these two waves coming. Now they are interfering, right? Now, why is it called destructive interference? Total destructive interference. Let's observe something before I show you the resultant effects of this wave. Look at this yellow, and this is the crest. Look at this one, this white. You see that the crest of one corresponds to the draw of the other. And the phase angle is 180 degrees. So which means that these two waves, they are interfering and they have the same frequency, the same amplitude, and their phase angle is different. Phase angle between them is 180 degrees. It now implies that these two waves will cancel each other gently. That is why we call them destructive.
They are going to destroy each other.
And then we are going to have a resulting effect. Look at it back. We look at the wave that we now have. Look at it. No wave again. They are going to cancel each other because they are interfering destructively. Total destructive interference. Now have another interference. Look at it. The same frequency, the same wavelength. Now let's observe something. Compare it with the former one. Can you see it? That the phase angle here is not 180, but they are of the same frequency, of the same amplitude. So we are going to have a resultant wave, isn't it? That is having its own amplitude. Let's observe it. This is the resultant wave. and we see that it is not cancelling each other. They don't cancel each other totally. We have partial destructive interference. Now let me say this. How can we apply this interference, this total destructive interference or destructive interference? How can we apply it? And don't let us just learn book alone. Let's talk about the practical application. Destructive interference. This can be applied in noise cancellation headphone. You see that noise cancellation headphone that I used to buy? This is the working principle of the noise cancellation. We have some headphone. You will label something and then you will not put that thing inside that thing. You will label some headphone, noise cancellation headphone, and I will be using the headphone. I can still be hearing noise outside. Abba, for God's sake. Abba. I will sue you. Now, noise cancellation headphone. This is the working principle. There is a chip inside that headphone. Now, you see that chip is going to be listening to external sound, noise outside. Now, as it is listening to that noise outside, it will now produce a wave that is similar to that wave, so that the wave will now counterbalance each other. We now have destructive interference of the two waves. So that at the end of the day, as the noise is coming externally, before it enters into the mic or into the ear, into the mic of the headphone, the wave that the chip is generating will have cancelled it. That is one application of destructive interference. Now this one is partial. Oh yeah, observe this one. You see that this yellow is having what? Okay, more amplitude than this white. Okay, but they align. The phase angle is 180 degree. And at the end of the day, we have this resonant wave. They are not going to cancel each other because one is having an amplitude that is beyond the other one. So we still have partial destructive interference. When are you going to have total destructive interference? The two waves identical, they have the same frequency, they have the same wavelength, and their phase angle, the phase angle between them is 180. All right, let's leave that one. Another type of interference that we have is what I'm showing you. Belek. Now let's observe this one again. Okay. Are you saying something? They are aligned, isn't it? The two waves align. This is what is known as constructive interference. I laugh. Constructive interference. What do you observe? Let me show you again. Can you see that? Now, what do you observe? You observe that the two waves perfectly align with each other. The crest of one corresponds with the crest of the other. The trough of one corresponds with the trough of the other. Isn't it? That is what is known as constructive interference. What is now the resultant wave?
The resultant wave is this. We now have a wave that is having a big amplitude compared to the two waves.
Don't let us learn book. What is the application of this? Now, it's very simple. We used to do this in our church, in all. Now we are going to have multiple speakers. They will put one speaker here, put another speaker here, put another speaker here, put another speaker here. The wave coming out from each speaker, are they not going to interfere? The sound wave, they are going to interfere. What do you think will happen? We now end up. That is known as constructive interference. You know, we are constructing it. We want a loud sound in our church, in our mosques, in event center. So we use multiple speakers to produce different sound wave. And as this sound wave is coming together, we have a resultant wave that is having high amplitude. Alright. Now we have progressive wave. Let's learn progressive wave properly. And when we talk about progressive wave, and they are also known as traveling wave. We don't want to say progressive wave. We say what? Traveling wave. And this wave, they carry energy from one point to the other. So this one, we just carry energy from one point to the other. Okay. Now for progressive wave can be transverse in nature. Transverse wave. For transverse wave, you see the transverse wave. How is it being generated? I will still show you the animation. Let me explain first. Now for transverse wave, The wave will move perpendicularly to the vibration of the source. What is actually producing the wave? It will be vibrating up and down. Let's say it's vibrating up and down. Now, the wave that is generated will now move straight. The angle between the vibration direction and the wave movement, the propagation of the wave, the angle between them will now be 90 degrees. That is called transverse wave. Examples of transverse wave, as we can see here, is electromagnetic wave, thick wave, light wave, X-ray, gamma ray, radio wave, ultraviolet ray, radio wave, X-ray, gamma ray, infrared. They are all electromagnetic waves. All electromagnetic waves are transverse wave. Master this. Don't miss this. If you miss this, you need K. What do you want to get again in your exam? When they ask which of the following is not an example of transverse wave and you are missing it for God's sake, what do you want to get again? Answer in the comment section. Which question do you want to get again? All electromagnetic waves are transverse wave. I won't say that again. Another example of transverse wave, we have water ripples, we have seismic wave. Seismic wave is the wave coming from the earthquake. Now the ground will be shaking. They are also transverse wave. That's transverse wave. Now let's learn longitudinal wave. Longitudinal wave. The difference between transverse wave and longitudinal wave is their direction. Now for longitudinal wave, this one will just be traveling parallel with the vibration direction, parallel with the source. The vibration that is producing the wave will now be traveling parallel to it. If it is moving up and down, the wave will now be moving straight up and down. So that is known as longitudinal wave. Examples of longitudinal waves: sound wave. Sound waves are longitudinal. You still want to miss this question again? Sound wave, mechanical wave. Sound wave is also longitudinal wave. That sound wave, it can be progressive in nature. Progressive. It can also be what? Standing. You see, I'm telling you. But sound wave is longitudinal wave and it's also mechanical wave. Okay, let's go back. I know some of you still want to miss this question. Don't miss it. Let's go back. How is sound being produced? Sound is produced by what? By what? By vibration. That is how we produce sound. Vibration must occur before sound will be produced. Oh yeah, as I'm talking, what do you think is happening? All my vocal organs, all my, what was it called? I've forgotten in English language. Now you remember me, I don't remember. No sabi English. The vocal organs. Your tongue, we have we have fricative sound, we have affricative sound, everything. There shall be something that will vibrate before you produce sound. At times your throat will move to produce sound. Your lips, your tongue, your teeth, they are moving, vibrating, producing sound, sound wave. Okay, let's leave that one. Clap your hand. As you are clapping your hands, your hand is shaking, isn't it? There's something is vibrating, producing sound. Okay, let's beat drum. As you are beating the drum, the membrane is also vibrating, producing sound. Oh yeah, let's play flutes and trumpet. As you are blowing inside the trumpet, the air is vibrating. We have refraction and compression of air to produce sound. That is mechanical wave. All I just explained, they are all types of mechanical wave. Stop shabejo. Let's move forward. Another example of longitudinal wave, we have sound wave, pressure wave, and compression waves. Okay, now we have ended this class. But before we end this class, I know some of you are stubborn. You will watch video, you will not like, you will not comment because it's not comedy. And you will watch this video and get some question in your exam and you will not like, you need deliverance. Now let's see how to answer this question. Which of the following medium allows transmission of sound waves? I, air, I, liquid, I, solid. Now I will not tell you the answer. You pick the correct answer and comment in the comment section. If you like, don't comment. If you like, comment. If you like, don't comment. Just be watching, don't comment. I'll pick the correct answer here and comment it in the comment section. Or have you learned anything in this video? Just comment in the comment section. Let's look at the second question. Sound wave is dash and dash type of wave. I think I mentioned that in this video. Oh, yeah. Let me see if you understand it. Answer this question and comment it in the comment section. Give this video a thumbs up. In our next video, we answer this question and we now look at that thing that is disturbing you. I know some of you, that is what you are looking for. Progressive wave equation. It's very simple, Jerry. We are going to learn. Now, what have we learned in this video? We are able to talk about, we talk about wave, definition of wave, types of wave, properties of wave. And what are the types of wave that we have? We use different classification according to what? To the medium. We said we have mechanical, we have electromagnetic. Now, according to what? Energy. How the energy is moving. The energy, we talked about standing wave and progressive wave. And we're talking about the direction of movement. We talked about transverse wave and longitudinal wave. Now, those are the things that we discussed. We also discussed about properties of wave. Now, all the properties of wave in this video that I mentioned, it is for all types of wave. There are still some properties that I didn't mention that is not for all the wave, like polarization. Polarization is only meant for electromagnetic wave. That is why I didn't put it here. Now, alright, we talk about diffraction, spreading of wave when it's passed through small opening or when it encounters obstacles. We talk about refraction when wave is moving from one medium to the other, the bending of the wave or the changing direction of the wave. We talk about reflection, change in direction of wave when it encounters an obstacle. So those are the properties that we talked about. Finally, we even talked about what? Interference, which means that wave can interact with each other. Talk about destructive interference, constructive interference. Alright, give this video a thumbs up, like this video, share this video, make sure you subscribe to our channel if you haven't gotten your app, and make sure you download your app. Download Exam Scholar app now. See you in the next video.